this course on advanced manufacturing methods, and I hope that you will be benefited by this course. In this course, main areas which we will be dealing with is basically on non-traditional machining, what we call as non-traditional machining, but we would like to cover the other areas also, the materials and the machining parts of the advanced manufacturing methods. And I think that this course will be of much importance to you, as it is almost now the syllabus content, as far as the syllabus contents are concerned, for mechanical engineering, for production engineering, and other related branches. This is the part of the curriculum, your advances in manufacturing technologies, and this should be of great interest to you also, that what are the latest technologies which we are following, right? So, as you know that today we have with us Dr. S.S. Banwat. He is professor and head in mechanical engineering department, and we would like to I would like to welcome him for this inaugural session on AMM, and with this I will hand over to Dr. Banwat for giving us a guidance on this course.
Yeah, good morning all of you. See, this course, in fact, Professor Jessel is an expert in this area, and he has been conducting this course regularly. And after seeing this timetable, I've seen many experts who are doing, in fact, PhD work on this topic. Specifically, we have Professor Manna from PEC, and I like to tell you that while attending these classes, try to interact with the experts and explore your things that in which topic you are specifically interested. You can interact with them and can get some inputs in that area from them, rather than being a one-sided affair that experts go on talking. Okay, I'm particularly interested to have an interactive session with you so that you are able to gain something from these experts, because these are the people who are doing research in that area, and you may be interested in some other area in which you wanted to work in that. Okay, so both Rao and Jessel are the coordinator of this course, and a good number of experts have been invited with from various institutes. I'm seeing we'll be having sessions from Dr. Kansal also, who's a professor at UIT. He's also working in this area for the last decade, and I hope that this course will be of beneficial to you, and I now request Jessel to continue the session.
Okay, thank you, Dr. Banwat, very much. As you know that we are now two coordinators, Mr. P.S. Rao and myself, and as I am busy with my other course also, I am attending one training program which is from UKRE, and it is clashing since the dates have clashed. So I will be there for 3 days, and hopefully I will be meeting you on Thursday and Friday. I will take care. Until then time, Rao Saab will be your coordinating. You please contact him. Since you can contact me also. After 4 o'clock I would be free, but till that time, till Wednesday, you disturb Mr. Rao for anything else, for your anything else, like if you have any problem with your stay arrangements or food arrangements like that. Yes. Please don't hesitate. please let us know, and we will try our level best to solve the problems. Right. I hope that you enjoy the course. Uh, Dr. Rao, Rao, sir, you will like to say something? Okay. Okay. Thank you, Rao, sir, for your efforts for conducting this course. I would now I would thank Dr. Banwat for sparing his valuable time for the inauguration of this course. Thank you very much, sir.
So you can continue.
Yeah, with this, we'll continue with our first session on introduction to AMM. Right? Okay. Okay. Thank you. लगा दिया? अच्छा, इससे बैठ इसकी स्क्रीन ना थोड़ी स्क्रीन इसकी आती है ऐसे वैसे किसी तरीके से ऐसे दिख नहीं रहा मेरे को रिफ्लेक्शन बहुत पड़ रही है वो होगा या तो मेरे को ऐसे करके देखना पड़ेगा ऐसे ही ये वाली है ट्यूबलाइट ठीक हाँ अंधेरा हो गया वैसे अब ठीक है कोई नहीं ये अभी वो सेंटर जुड़ा है क्या आरडी जुड़ गया थोड़ा सा एक बार वो शॉर्ट दिखा दो ना कोई जुड़ा है तो नहीं तो फिर उनको उनको भी वेलकम कर दें चलिए कोई बात नहीं
थोड़ा सा इंटरेक्टिव कर लेना ना जिससे सेशन है इनके साथ थोड़ा फिर वो
हाँ बस
एक स्पीड नहीं तो वन साइडेड ज्यादा हो जाती है इससे थोड़ा इंटरेक्ट करते रहोगे तो ठीक चलेगा
the topic is advanced machining processes. First, I would like to take not directly you to the machining processes. I would like to discuss about the what are the advances in, let us say, mechanical engineering first. I hope that this clipping would be of interest to you. So first, let us see what BMW is doing. They have a very good. I got a very good clipping over here. साउंड चल रहा है ना ऐसे नहीं तो मैं बोलता रहूंगा तो कोई बात नहीं ऐसे ये BMW का ज्यूरिक प्लांट है जो वहां पर BMW कार्स की असेंबली हो रही है इसमें चलो फिर चाय के बाद ही शुरू कर लेते हैं कोई बात नहीं है पहले चाय पी लो कोई बात नहीं फिर शुरू करते हैं सेंटर भी जुड़ जाएगा ना हाँ चलो ये भी ठीक रहेगा इसका ट्रांसमिशन कैसे हो रहा है क्यों इसका ट्रांसमिशन ठीक हो रहा है वहां पर मैं जस्ट वो देखना चाहता हूँ कि मैं उतने की दिखाऊं फिर वो जो क्लिपिंग्स है उसमें अच्छा, इसमें तो ठीक दिख रहा है हमें वैसे। यही जाएगा, ये क्वालिटी जाएगी। ओके, थैंक यू। चलिए ऐसे करते हैं फिर, अपन थोड़ा सा पहले चाय पी लेते हैं, फिर 10 एक मिनट के बाद अपन शुरू करते हैं। what hmm. So what are the main features? Huh. So what are the main features you have noted down in this clip? Automatic, yeah. We have also automation nowadays in our manufacturing facilities also we have this type of facilities, but we don't have the automation to that much degree, we can say. There it is almost like a almost robots are handling, huh? Negligible manpower is there, huh? You can say. and and you have seen the faces of the persons who are working over there. So have you noted the difference, any difference over there? They don't have that type of tension on their faces, eh? Rather they are happy. हाँ, rather they are very happy to do the work. साढ़े इतने तो होता है कि ऐसे लगता है कि मार के खड़ा किया हुआ होता है ना, कि थप्पड़ मार के कि हाँ जी। असेंबली करने समय भी बहुत प्रॉब्लम होती है क्योंकि पार्ट्स एक्यूरेट ही नहीं बनते हैं। हाँ हाँ, इनके यहाँ जो मशीन्स है, जो जो वैसे इन गाड़ियों की वैसे खासियत ही यही है कि जो है कि आपको किसी स्पेयर पार्ट्स की जरूरत नहीं पड़ती है, अनलेस एंड अनटिल इट इज कि आपका कहीं कोई एक्सीडेंट हो गया हो या ब्रेकडाउन में हो गया हो, कुछ ऐसा इस टाइप का जब तक नहीं होता है तब तक गाड़ी को स्पेयर पार्ट की जरूरत नहीं पड़ती है, जब तक उसकी लाइफ है उस पार्ट की, वेदर इट इज 1 लाख किलोमीटर्स और वेदर इट इज 10,000 किलोमीटर्स लाइक दैट। तो ये एक चीज अप्रोच का फर्क है हमारे, वैसे ना ये कह सकते हैं हम, या ये भी कह सकते हैं कि दृष्टिकोण का फर्क है हमारे यहाँ, है ना। हमारे यहाँ जो एटीट्यूड है कि जो चलता है सब उसके कारण जो है हम चाहे जितनी मर्जी एडवांस मशीन ले आए लेकिन उसको हम उस तरह से ऑपरेट ही नहीं करते। इसी की वजह से हमें वो रिजल्ट्स नहीं मिल पाते हैं वैसे, क्योंकि हम उसको स्पिरिट के साथ जो है इम्प्लीमेंट नहीं कर पाते हैं, है ना। मशीन्स तो हमारे यहाँ भी आज की डेट में भी वही है ना। हमारे पास भी वही टेक्नोलॉजी है वैसे जो उनके पास है, ज्यादा से ज्यादा इतना फर्क हो सकता है कि हम उनसे 5 साल पीछे होंगे, है ना। जो मशीन उनके यहाँ पर 5 साल पहले आ जाती है वो हमारे यहाँ पर आज 5 साल के बाद आती है एक तरह से, लेकिन जो मेन डिफरेंस है वो है एटीट्यूड का फर्क है। हाँ जी। हम्म हम्म पर ऐसा है कि जैसे हमारे यहाँ पर अभी भी जो है आपने देखा होगा MiG-23 और ये इस टाइप के फाइटर एयरक्राफ्ट चल रहे हैं वैसे, है ना? वो हमारी आर्मी या एयरफोर्स के पास जो है वो किस तरह से मेंटेन कर रहे हैं वैसे, हम क्यों नहीं कर पा रहे हैं उसमें? हाँ जी। नहीं नहीं, ऐसा कुछ नहीं है। इसमें जो मेन डिफरेंस है वो है कि हमारे सोच नहीं है वैसी, एक्चुअली में हम करना नहीं चाहते हैं। हाँ जी। हाँ, तो हमारे यहाँ काम तो यही होता है ना कि हम लेटर फाइल मोटी करने में विश्वास रखते हैं, कागज कागज काले करने में हम ज्यादा विश्वास रखते हैं ऐसे। नहीं, वो ठीक है आपकी बात है, पर अगर जहां तक मशीन खराब है, मेरे को नहीं लगता कि सिर्फ एक ही कंपोनेंट ऐसा होगा कि जो ज्यादा सारी मशीनों में खराब होगा। आप सिंपल सी एक अप्रोच ये भी लगा सकते हो कि 4 मशीनें खोली तो उसमें से जो है जो पार्ट अच्छे हैं उनको असेंबल करके एक तो बना ही सकते हैं वैसे, है? है? हाँ, नहीं जो जो जैसे एयरफोर्स जो करती है वो ये करती है कि रिवर्स इंजीनियरिंग करके वो कम जो भी पार्ट खराब हुआ है उसको फिर से बना लेती है? उसमें रीवर्क करके या किसी भी तरह से जो है उसको वर्क करके। तो वो किस मेथड से करते हैं वैसे, उसका पता है आपको? आपने आपने सुना होगा कि एक एक मशीन होती है कोऑर्डिनेट मेजरिंग मशीन। अभी शायद मेरे पास वैसे उसकी क्लिपिंग नहीं है वैसे, बट कोऑर्डिनेट 3D कोऑर्डिनेट मेजरिंग मशीन्स होती है। उसका क्या फंक्शन क्या काम क्या है उसका, कि रिवर्स इंजीनियरिंग करनी है। आपने कोई कंपोनेंट रख दिया है, वो उसकी क्या डायमेंशंस हैं, राइट? आप उसके डायमीटर ले सकते हैं, टेपर ले सकते हैं, सारा कुछ मेजर कर सकते हैं। बेसिकली आपने क्या करना है कि आपने 3D पॉइंट्स पिक करने हैं, एक्स वाई जेड और कोऑर्डिनेट्स जो है वो पिक करने हैं, वो मशीन ने पिक करने। और जैसे हम ड्राइंग में बनाते हैं, है ना? आजकल जो हम 3D ड्राइंग बनाते हैं, जैसे 3D में ड्राइंग बनाते हैं कैटिया या रोई में, तो उसमें भी क्या करते हैं, हमें एक वैल्यू देनी पड़ती है एक्स वाई जेड कोऑर्डिनेट्स की, तब एक लाइन ड्रॉ होती है, या कर्व ड्रॉ होता है, उससे फिर सॉलिड बनता है। तो ये रिवर्स कर रहे हैं हम। पहले हमने जो है कंपोनेंट के बाहर से सारा एक उसका 3D एक्स वाई जेड कोऑर्डिनेट्स जगह जगह पे वैल्यूज ले ली, और उसके अकॉर्डिंगली अब उसकी प्रोफाइल बना ली, है ना? तो हमारे पास वो प्रोफाइल के कोऑर्डिनेट्स आ गए, राइट? तो उससे हम जो है फिर से सीएनसी में जाके वही कंपोनेंट्स उसी साइज का बना सकते हैं ना, राइट? आपने देखी नहीं है वैसे वो मशीन किसी ने भी, है? अच्छा।
मटेरियल कहाँ से लाएंगे सर, बना सकते हैं 3D में मशीन सीएनसी पे कोऑर्डिनेट मेजर कर लेंगे, लेकिन
हाँ
जो
जी।
हाइड्रोजन प्लेट और सब में जो मटेरियल चाहिए
हाँ जी।
को अपने यहाँ तो
अब क्या है मटेरियल,
इम्पोर्ट कर।
नहीं लेकिन मटेरियल एनालिसिस करके भी आप जो है वैसे काफी कुछ उसके आसपास पहुंच सकते हो वैसे, उस वैल्यूज के कि भाई उसकी क्या स्ट्रेंथ है, टेंसाइल स्ट्रेंथ क्या है, या उसकी डक्टिलिटी कितनी है, या उसकी है। हाँ, तो प्रॉपर प्रॉपर मिलने के लिए तो यही होता है कि कोई कोई उसको नए सिरे से डिजाइन करे, या तो है ना, है? तब जो है, और ऐसा भी कुछ नहीं है, हम आसपास के मटेरियल्स जो हैं वो इंपोर्ट करते रहते हैं, हमारे पास भी मटेरियल्स हैं ऐसे इस टाइप के। मतलब नीड नॉट बी कि हम उसको मैन्युफैक्चर ही करते हो यहाँ पर, लेकिन बनते हैं ऑल ओवर वर्ल्ड, बनते हैं और मिल जाते हैं, ऐसा कुछ नहीं है। जो आज भी जो है आपकी बड़ी बड़ी फैक्ट्रीज जो है वो, या ये लोग कहाँ से प्रोक्योर कर रहे हैं, जैसे आपकी हमारे यहाँ पर भी इंडियन कार मैन्युफैक्चरर्स हैं, वो लोग भी तो कहीं ना कहीं से प्रोक्योर करते हैं ना। वो मटेरियल्स मिलते हैं, ऐसी बात नहीं है कि नहीं मिलते हैं, बट उनका बैच साइज या लॉट साइज का फर्क होता है, हमारे यहाँ का फर्क होता है ना? जो हमने करना है वो शायद आपने एक आध कंपोनेंट के लिए करना है, रिवर्स इंजीनियरिंग के लिए जैसे आपको चाहिए है, तो वैसे उन्होंने जो है मास प्रोडक्शन में मास के लिए ऑर्डर करना है, तो रेट का थोड़ा सा फर्क पड़ जाता है, बट हाँ वो उस चीज का फर्क तो पड़ता है, लेकिन ये मेन चीज ये रहती है कि वेदर हमने उसको एक चैलेंज की तरह लिया है या वैसे के वैसे ही छोड़ दिया कि चलो ठीक है जी डंप रहने देते हैं हम, है ना? वो भी है। कई बार कंस्ट्रेंट्स तो सभी जगह होते हैं देखो, है ना? सभी के कंस्ट्रेंट्स होते हैं, कुछ के डिफरेंट होते हैं, कुछ के डिफरेंट होते हैं, सिचुएशंस अलग अलग होती है, अकॉर्डिंगली कंडीशंस जो है उस हिसाब से रहती हैं। तो कंस्ट्रेंट्स वेरी करते रहते हैं, कम ज्यादा हो सकते हैं, डिग्री का फर्क हो सकता है? लेकिन अगर हम अप्रोच ही ये रखेंगे कि करना ही नहीं है तो फिर नहीं होगा, है ना? या हम अटेम्प्ट करने से पहले ही हार मान गए, मतलब एक तरह से ये कह लीजिए। अच्छा, ये है काफी कुछ, ये सारी की सारी नॉन कन्वेंशनल मशीनिंग्स हैं जो भी आप लोगों ने अपने सब्जेक्ट एरियाज में भी पढ़ी होंगी, है? इसमें क्या क्या है वो हम देखते हैं। जैसे कि ये है केमिकल मिलिंग, फोटोकेमिकल ब्लैंकिंग, इलेक्ट्रोकेमिकल मशीनिंग, पल्स्ड इलेक्ट्रोकेमिकल मशीनिंग, इलेक्ट्रोकेमिकल ग्राइंडिंग, इलेक्ट्रिकल डिस्चार्ज मशीनिंग, इलेक्ट्रिकल डिस्चार्ज ग्राइंडिंग, देन इलेक्ट्रिकल डिस्चार्ज वायर कटिंग, लेजर बीम मशीनिंग, इलेक्ट्रॉन बीम मशीनिंग, प्लाज्मा आर्क कटिंग, वाटर जेट मशीनिंग, एब्रेसिव वाटर जेट मशीनिंग एंड एब्रेसिव जेट मशीनिंग। इसके अलावा और भी है, हाँ, अल्ट्रासोनिक मशीनिंग है। तो इसमें से आप लोगों ने काफी काफी कुछ पढ़ी हुई होंगी शायद, या फैमिलियर होंगे इनसे। जो हमारे आगे के टॉपिक्स हैं वो इन्हीं पे है। तो आज अभी जो था ये लेक्चर थोड़ा सा ब्रीफ आपको जस्ट इसके मोटा मोटा इसमें बताएंगे, फिर उसके बाद जो जैसे जैसे एक एक एक्सपर्ट आते जाएंगे वो अपना इस एरिया में आपको डिटेल में बताते जाएंगे, राइट। ये जितनी भी टेक्नोलॉजीज हैं ये सारी की सारी ज्यादातर वैसे कब डेवलप हुई हैं? वर्ल्ड वॉर के बाद। हाँ, ऐसा क्यों, क्या रीजन क्या है, वर्ल्ड वॉर में ऐसा क्या हो गया कि भाई जो है नीड नीड यार, नीड इज द मदर ऑफ ऑल इन्वेंशंस है, वी कैन से, और डिस्कवरीज। तो उस समय ऐसी क्या जरूरत पड़ी हुई थी कि भाई जो है कि इतनी ज्यादा टेक्नोलॉजिकल एडवांसमेंट्स हुई?
मटेरियल डेवलप उसी तरह मशीनिंग डेवलप करनी पे मॉडर्न मशीनिंग करनी है जिसका मटेरियल डेवलप।
हाँ, उस समय हम कह सकते हैं कि न्यू न्यू मटेरियल्स का, हार्ड मटेरियल्स का डिस्कवरी हुई, हाँ? बहुत सारे नए मटेरियल्स जो है वो खोजे गए, और उस समय पे ये प्रॉब्लम आई कि भाई अब इनको मशीन कैसे करना है। क्योंकि अभी जो हमारी बेसिक मशीनिंग की फिलॉसफी है वो है कि कटिंग काय से करनी है, हमने हार्डर मटेरियल से करनी है, सॉफ्टवेयर मटेरियल की कटिंग हार्डर मटेरियल से करनी है ना। तो लेकिन एक लिमिट है, अगर हार्ड मटेरियल की मशीनिंग करनी तो फिर उसके हार्डर मटेरियल की ढूंढना पड़ेगा, और हार्डर के लिए हार्डेस्ट ढूंढना पड़ेगा। तो कहीं ना कहीं जाके तो एक जगह जाके रुक जाता है, सुई रुक जाती है। तो उसको हम कैसे करेंगे फिर? उसके लिए जो है ये सारी की सारी नॉन कन्वेंशनल मशीनिंग डेवलप हुई। क्योंकि आपने देखा होगा कि मटेरियल चाहे कितना भी सॉफ्ट हो, अगर उसको अगर हम काट रहे हैं तो जो काटने वाला मटेरियल है वो भी थोड़ा बहुत तो घिसता ही है। इट मे बी नेग्लिजिबल एज कंपेयर टू द मटेरियल विच वी आर कटिंग। अगर उसको एक टाइम फ्रेम में देखें हम, तो लॉन्ग लॉन्ग टाइम में अगर उस प्रोसेस को देखें तो वो हमें समझ में आती है फिर चीज कि हाँ ये कैसे हो रहा है। उसका कोई एग्जांपल आपके दिमाग में आता हो ऐसे कि टाइम के साथ आपने चीजों को घिसते हुए देखा हो, सॉफ्ट बहुत हार्ड मटेरियल्स को भी थ्रू बहुत सॉफ्ट मटेरियल से ऐसे।
बहुत सारे हाई स्पीड स्टील के जो हमारे कटिंग टूल्स होते हैं सारे टाइम स्टार्ट हो जाते हैं।
हाँ, वो होते हैं जैसे एक छोटा सा, हाँ छोड़ सिंपल सा कोई एग्जांपल दे दो बस अगर। हाँ जी। आपने पुराने कुएं में देखा होगा कि पानी खींचते होते थे, रस्सी से बाल्टी निकालते होते थे, तो वो रस्सी जो थी वो भी काट देती थी उसको, पत्थर को है। हाँ, तो पानी की बूंद से जो है, आपने पानी से जो है बहुत सारे स्कल्पचर्स बनते हुए देखे होंगे, और पानी से कटिंग भी होती हुई देखी होगी, है ना। जो हमारी नदियां बनी हुई हैं सारी, उनका फ्लो कैसे बना है? आपने पहाड़ों में देखा होगा कि नदी जो है पहाड़ को काटते हुए चले जाती है। वो क्या चीज है? दैट इज एब्रेसिव ग्राइंडिंग, वी कैन से मशीनिंग है या ग्राइंडिंग है। अब जगर जगर वो चीज भी मशीनिंग है या है वो कटिंग है ना। सो व्हाट इज द डिफरेंस बिटवीन मशीनिंग एंड कटिंग? ये क्वेश्चन उठता है अब। सो कटिंग में क्या हो रहा है? हाँ जी। हाँ, कटिंग में ये कह सकते हैं हम कि हमारे पैरामीटर्स हमारे कंट्रोल में नहीं है ना। जहां पर हम चाहते हैं पर्टिकुलरली वहीं पे कटिंग हो, हमारे पास कोई ऐसा मैकेनिज्म नहीं होता है कटिंग में। लेकिन मशीनिंग में क्या करते हैं, हम उसी चीज को कंसंट्रेटेड एफर्ट के साथ वहीं पे काटते हैं जहां पर रिक्वायर्ड है, राइट। तो हम उसको फिर मशीनिंग कह देते हैं, उस कटिंग को हम मशीनिंग कह देते हैं, right? कि जहां पर कि पैरामीटर्स सारे हमारे कंट्रोल में हों। अगर आप इसमें गौर फरमाएंगे तो देखेंगे कि भाई ये जितनी भी प्रोसेसेस हैं ये ज्यादातर वैसे आपकी कन्वेंशनल प्रोसेसेस ही हैं, बट उसको सिर्फ देखने का नजरिया जो है वो उल्टा किया है हमने। फॉर एग्जाम्पल, अगर जैसे हम इलेक्ट्रिकल डिस्चार्ज मशीनिंग की बात करें, पहले उस पर चलते हैं। ये क्या है, यूजेस ए शेप्ड इलेक्ट्रोड एंड इलेक्ट्रिक स्पार्क्स टू रिमूव मेटल and discharges sparks at about 50 to 500 kilohertz. एक शेप्ड इलेक्ट्रोड से, आपने देखी है वैसे ईडीएम की प्रोसेस है, या नहीं तो मैं आपको एक क्लिपिंग भी दिखा सकता हूँ, मेरे पास है। ईडीएम इसमें लगता रह गई है नहीं इसके अंदर। चलिए इसमें वैसे हम वैसे इसी में से देख लेते हैं, कोई बात नहीं। इस डायग्राम में अगर आप देखेंगे तो आपको एक वर्कपीस और टूल दिख रहा है। ये हमारा वर्कपीस है, ये टूल है। इसके अंदर हमने ये जो टूल है बेसिकली उसी शेप का बनाना है, आपने उसका अपोजिट बनाना है, जो जो शेप आपको चाहिए। जैसे कि फॉर एग्जांपल अगर मान लो इसी की टिप के ऊपर हमें कॉइन पे जो शेप बनी हुई होती है, मान लो जो फिगर बनी हुई है, अब किसी के एक बंदे की फोटो बनी हुई है उसके ऊपर, और उसके ऊपर कंट्री का नाम लिखा हुआ है एंड उसके डिनोमिनेशन लिखी हुई है उस कॉइन की, वो सारी चीजें करनी है तो वो पहले उसका टूल जो है वो उसी शेप का बनाना पड़ेगा, उसका अपोजिट जो हमें चाहिए। तो उस टूल को हम जो है इसके ऊपर वर्कपीस के ऊपर रखेंगे और थ्रू डाई इलेक्ट्रिक उसके अंदर एक किसी मीडियम के अंदर उसको डुबोएंगे जिसको हम डाई इलेक्ट्रिक कहते हैं, राइट। और उसके अंदर जो है इलेक्ट्रिसिटी पास करेंगे, जो हम फ्रीक्वेंसी की बात कर रहे थे 50 to 500 हर्ट्ज की, राइट। तो क्या होगा कि जो वर्कपीस मटेरियल है उसमें स्पार्किंग होगी और वो मटेरियल जो है वहां से धीरे धीरे स्पार्किंग से इरोजन होते जाएगा। जैसे आपने देखा होगा, जैसे कि आपने देखा होगा कि स्पार्क प्लग जो रहता है अपना, वो इरोड होता रहता है, या जो अगर हमारा बिजली का स्विच है जो है वो वहां से हम जब ऑन करते हैं तो एक स्पार्क जो है वो जंप करती है ना, बिकॉज ऑफ द पोटेंशियल डिफरेंस। तो जब वो जंप करती है तो एक छोटा सा जो है मटेरियल, बहुत ही टाइनी मटेरियल जो है, वो वहां से इरोड कर जाता, निकल जाता है वहां पर। उसी तरह से जब टाइम के साथ अगर हम देखें तो वहां पर वो आपको थोड़ा सा गड्ढा सा दिखता है और काला काला सा दिखता है ना, इसके ऊपर कार्बन वगैरह आ जाता है, राइट। वही टेक्नोलॉजी है जिसको हमने अब जो है मशीनिंग का नाम दे दिया, कंट्रोल कर लिया है, क्योंकि अब इसमें अब एक एक बार अगर स्विच ऑन करेंगे ऑफ करेंगे तो क्या होगा कि टाइम बहुत ज्यादा लगेगा उसको मशीन करने में, और मटेरियल बहुत कम निकल रहा है। तो उसको फास्ट करने का क्या तरीका है कि ये काम जो है मशीन को दे दिया जाए, जो कि बार बार जो है ऑन करेगी और ऑफ करेगी, राइट। तो वो साइकिल्स के थ्रू हम क्या कर रहे हैं उसको, वो थ्रू एक तरह से पल्स जनरेटर से कर रहे हैं। इसके अंदर एक डीसी पल्स जनरेटर लगा हुआ होता है कि जो साइकिल को ऊपर और नीचे ऐसे वी शेप्स में ला ला के करंट को, राइट, करंट बढ़ाता है कम करता है, तो वो स्पार्क जो है वो जंप करती है उसके बीच में, right? वो फ्रिक्वेंसी की बात कर रहे हैं हम, है ना। वो काम हम और अब हमने जो है उसकी साइकिल इतनी नंबर ऑफ टाइम्स इतना ज्यादा इंक्रीज कर दिया, कितना है वो 50 टू 500 हर्ट्ज। 50 हर्ट्ज का क्या मतलब हुआ वैसे? हाँ जी, नहीं, हर्ट्ज, हर्ट्ज का क्या यूनिट होता है वैसे? हाँ जी, फ्रीक्वेंसी है, दैट इज फ्रीक्वेंसी, बट 50 का क्या मतलब हुआ जगह, कितने टाइम में? दैट इज पर सेकंड, एक एक हाँ, एक एक सेकंड में 50 बार हो रहा है, या हम उसको 500 टाइम्स भी कर सकते हैं, हाँ? उसको हम बढ़ा घटा सकते हैं नंबर ऑफ टाइम्स। नहीं, क्योंकि हमको मशीनिंग, हमारा टारगेट क्या है, हमने मशीनिंग करनी है अब उसकी, हमने उसको लेके नहीं बैठे रहना कि हाँ जी जो है धीरे 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 है करते रहेंगे। सरफेस फिनिश के अलावा जो अब मटेरियल निकल रहा है, जैसे आपने स्पार्क में नोट किया होगा कि मटेरियल कितना निकलता है उसमें। नहीं, वेपोराइज तो ठीक है, पर कितना हो रहा है, इतना हो रहा है या इतना सा हो रहा है या इतना हो रहा है? वो क्वांटिटी के ऊपर डिपेंड करता है ना, है। जब आपका सिर्फ एटॉमिक लेवल पे ही निकलना है उसने जरा सा, कि एक एक एटम जो है वो ही निकल रहा है सिर्फ, है? उतना माइन्यूट जो है माइक्रॉन्स में मशीनिंग हो रही है आपकी, तो फिर वो माइक्रॉन्स को अगर आपको उसको सेंटीमीटर्स में अगर आपने ड्रिल करना है या उस शेप को लेके आना है, या उसके लिए मान लो, है ना, तो उसके लिए कितनी कितनी डेप्थ है, तो कितना चाहिए होगा उसके लिए, राइट। हाँ, अब ये एक बहुत अच्छा क्वेश्चन है वैसे, कि मटेरियल पे डिपेंड करता है कि नहीं करता है ना। लकीली ये है कि ईडीएम में कोई भी मटेरियल हो, सब एक ही, रफली ये हम कह सकते हैं कि एक ही रेट से मशीन होते हैं। क्यों? क्योंकि सबके अंदर जो है वही डिस्चार्ज हो रहा है, सिर्फ क्या रहता है कि करंट हमारे को बढ़ाना, किसी में ज्यादा करंट करना पड़ता है, जो हार्डर मटेरियल होता है उसमें हमें करंट बढ़ाना पड़ता है, राइट? और जो सॉफ्टवेयर मटेरियल होता है वो आपका इजीली इजीली मशीन होता है ना, सॉफ्टवेयर मटेरियल हमेशा। क्यों होता है, उसका क्या रीजन है? क्योंकि उसके जो बॉन्ड्स हैं वो वीक हैं, जो आपके एटॉमिक बॉन्ड्स हैं, जो मॉलिक्यूलर बॉन्ड्स हैं उनके, वो वीक है। अब यहां पर आप क्या कर रहे हो, मशीनिंग जो है वो मॉलिक्यूलर लेवल पे कर रहे हो, right? आप उस मॉलिक्यूल में से वो एटॉमिक बॉन्डिंग उसकी तोड़ते हो, तब वो वहां से निकलता है, right? तो जो सॉफ्टवेयर मटेरियल है उसकी बॉन्डिंग स्ट्रेंथ जो है वो कम है, जो जितना हार्डर मटेरियल है वो उतना ज्यादा उसकी बॉन्डिंग स्ट्रेंथ ज्यादा है। तभी जो है उसकी, आपने देखा होगा जितने भी हार्ड मटेरियल्स हैं वो सारे के सारे वेट में ज्यादा होते हैं, है ना, हैवी होते हैं, उनकी डेंसिटी जो रहती है ज्यादा होती है? और उनको मशीन करना भी उतना ही डिफिकल्ट होता है। चलिए ये देखते हैं कि मशीनिंग से आजकल की हमारे डे टू डे लाइफ में क्या फर्क पड़ रहा है वैसे ना, है? ये देखिए, इसकी एक एप्लीकेशन है, ये आपका विजिटिंग कार्ड है, है ना? अच्छा, क्या इसकी वो एक मिनट ऑडियो नहीं मैं यहीं से कर देता हूँ। कौन से वाले ऑन कर दिया मैंने?
Purchasing our website.
इसको ऑफ करना पड़ेगा।
This is one of the Genavox manufacturing business cards. You can see it's pretty solid. It actually has a working planetary gear in the card. Gears are made of extruded acrylic, mirrored extruded acrylic. We can print barcodes, QR codes onto the card that we can actually track, and you can get results on the people scan them. This business card is a keeper. When you hand this one out, people hold on to it and hopefully can generate you some more sales. They're available for purchase on the website, genavox.com.
Okay. वॉल्यूम कम कर देता हूँ। For improving our daily life, you can say we are developing new applications of the existing processes, right? Like one example here is that they have developed a portable water cutting machine, and with this uh, we can do a lot of work which you can think of. This is a water jet machining. वो बंद कर दिया था साउंड साउंड ऑफ कर दिया
देखो बन रही है फिर आपकी नहीं तो आपकी ऑडियो नहीं जा रही यार माइक बंद करना पड़ेगा
okay. With this you can cut the steel girders also, right? This is abrasive water jet machining, right? Or water jet cutting, rather we can say it is a cutting, just like your plasma arc cuttings or oxyacetylene gas cuttings, like that. It's quite similar to that, but those are your thermal processes, right? In which we heat up the material up to the molten state and then the cutting is done. But here it is done with the help of a water jet, and with this portable machine means you can do a lot of maintenance work in it, and you can think of various applications of it. Just like you can say that this machine was used in your rescue operations in 9/11 blasts also of Twin Towers. The girders were cut by this machine, and in Nepal also it is used. The advantage of using water jet machining is that this is a eco-friendly process, you can say, and this is more suitable for the situation also, because in the debris of the buildings there can be persons buried beneath that, so we need to take care of that also, so that the temperatures are not very high, and the risk of fire is also eliminated by this process. Yeah, something, yes, some explosives can be there, or some open flame that can lead to open flames like that. Yes, aluminum oxides and different type of ox, just like your grinding wheel component abrasives. So this is the demonstration given on tire. You can cut it any material. This is useful for cutting the concrete blocks also, and for cutting glass also, like brittle materials like glass. Any brittle material can be cut. Any delicate materials can be cut. Nowadays, your not abrasive, water jet machining is mostly used in your cake cutting also. Because the cake is very soft material, so it is quite difficult to cut it with the help of a knife. So this is being cut by your specialized type of, you can say, water jet machinings. This is the cutting of the glass bottle being done by water jet machining. See, this is the cylinder drum you can cut. Any sheet metal type of thing. Suppose some explosive material is there in this you can say this is barrel. So, and you have to do perform some cutting operation on it. Then it is very useful like that, because without increasing the temperature, you are doing it. Your whole of the arrangement is moving on that chain actually. That is chain is guiding and as well as supporting that machine. So nowadays a lot of bombs are also being detonated by this technique. This is quite useful for bomb squads also. The application of the demonstration what we have seen on the drum, on the barrel, is useful in cutting the your large sides, large diameter pipelines actually. This machine can be useful in your uh, repairing of the rail tracks also, where you need to put extra. That is for welding, for joining. Thermite welding is for joining, but for cutting, you have to use the conventional. See, now you can see the this. This is a live bomb. This is being cut by your uh, water jet machining. This is a 500 kg aerial bomb. Now it is cutting the home steel door. Pressure around 500 psi, like that. Uh, But the main thing is that you have to concentrate that through a tip, through a nozzle. So we were here on the various machining processes. Let us go back to them. So this is the main processes which we have seen mostly. Let us see the one by one. What is chemical milling? Hmm? Chemical milling, any uh, idea of this or any example? What we do in chemical milling? Let us see. It produces shallow cavities on a workpiece, usually to reduce weight. The area affected by the chemical reagent is controlled by masking or by partial immersion. So So are you able to recognize this type of machining where you have seen emboss? Yes. This is mostly used for your PCB making. You can say. Have you seen ever that how the PCB is made? These are the examples of some of the parts made by your electrochemical machining. This is the airfoil of the shell body of the aeroplane, which is from which the weight is reduced by chemical milling, or you can say chemical machining. How it is made? How that machining is made? That we see, you can see the ribs on this part. First of all, the part is totally of uniform thickness, and now you want to reduce the weight of that part component, you can say, or the cover, you can say. Now you make the masking of the shape of the ribs like that, and you put the maskant on that plate or component, you can say. The purpose of the maskant is to so that there is no chemical reaction between the metal and the whatever chemical agent we are putting on it, right? So we have applied a maskant on there in the form of the shapes of the ribs, right? And then we dip the whole of the component in that chemical tank, right? So whatever parts are there which on which the maskant is not there, the chemical reacts with the metal and it erodes that metal over there. So this is mostly used just like your chemical. We have seen the ultrasonic cleaning of that cylinder block. It is quite similar to that process. Only thing is that this is a simple type of chemical reaction of the chemical and the metal, right? So this is used for mostly for reducing the weights of the, you can say, aeroplanes components or your missiles components like that. And in the case of PCB making, this is used for making the circuit boards. There you have to make the electrical connections between the various components, right? Your transistors, then your various triodes, diodes, like that. Various components are there, and in which you want a electrical connection. So you put the same technique by masking and by exposing the surfaces. Suppose you have drawn a line, so it will act as a maskant over there. Through. So this is the applications are aerospace industry, engravings, and circuit boards. Right? These are the three main areas. So shall I read or just we can skip? This is the process. This is the number one. This is how the steps are made. Different masking, first, second, third, like that. So what is the procedure? Relieve residual stresses to prevent warping. Clean the material surface. Apply masking material. Remove the masking on regions that require etching, and apply the reagents. Wash the part. Remove remaining masking, and additional finishing or chemical milling procedures may be used.
What are the masking materials?
Masking materials are generally which are not reactants, we can say, which do not chemically react with that chemical, right?
ये उसके रिप्लिका सर आते हैं अप्लाई कर देते हैं उसके
उसके ऊपर अप्लाई करते हैं, उसके ऊपर कोटिंग करते हैं उसकी, that is either through a pen maskants are also there for PCB making, pen maskants are there, हाँ? और स्प्रे कर सकते हैं, नहीं होगा। दिस इज फोटोकेमिकल ब्लैंकिंग, ये फोटो, in this process we use photographic processes to remove material, usually from a thin sheet. You must have seen the watch components, they are very, very small, quite small in size. So, there are some nowadays even smaller components are there which are the size of the microns. Some gears are there, some you must have seen on the Discovery Channel and other channels that some types of some artificial flies are made, no? Spying flies, in which you can see the size of the whole of the, you can say, helicopter is of the order of a small fly. So in which a camera is there, a motor is there, and so that it can fly, and there is a battery also to give it energy. So what would be the size of those components? They are all in microns. Suppose some motor is there, so motor must have some moving components, right? So what would be the size of the gears over there? Just like we can say the diameter of the gear would be the size of our hair size, like that. The thickness of our hair, human hair. That much small components are being made. So it is very difficult to make that components. So what we do is we increase the size of the, what we can do, we can increase the size by microscope, but that is viewing only. That is not making the actual size of the, we can say, it is only for viewing purpose, that through the microscope we can see them. So what we are doing is we use the photographic impression of that component and increase its size in the photograph, just like in a photography, in a photocopy machine, you can increase the size of your document by 200% and then again 200%, like that. So we are increasing the size of that component, and then we are exposing that that photographic film over a it is quite similar to, we can say, that process by which the earlier photographs were made, the black and white photographs. That film is quite similar to that, negative and positive type of thing, right? So it can produce complex shapes, since that is a photograph, so you can actually photograph it, so you need not be limited to your machines like that. So let us see what components. See, complex shapes can be made, and metal can be as thin as 0.0025 mm, which is, you can say, how many microns? 2.5 micron into 1000 करेंगे without forming berms. Here also we are using maskant, and we are exposing that material to the photographic impression through light. It is being, so these are the some of the parts which are made by photographic blanking, you can say. Are you able to recognize some of the part or the thickness of that one? Hmm? So what is the procedure of this is prepare the design at a magnification of up to 100 times. Make a photographic negative and reduce it to the size of the part. First we take the photographic impression and then first we magnify it. That magnification can be done with the help of a microscope, and then a photographic negative is taken and reduce it to the size of a part actually. Coat the blank with photosensitive material. A photosensitive material is which is sensitive to the light. Place the negative over the part and expose it to ultraviolet light to harden the exposed photosensitive coating. What we are doing is we are placing the negative over the part and exposing it to the through the ultraviolet light to harden the exposed photosensitive coating. Dissolve the unexposed coating and apply the chemical reagent. Remove. So now wherever the coating was not there, it will get dissolved, whole of the component, and we will get the shape of the component as which is being coated. Right. Then you have to simply remove the masking and wash the component. So what type of things we can make? Sharp corners and deep narrow cavities we cannot do. Steep tapers we should avoid. Then undercuts may develop, right? With the help, we can say with the components which are very thick. Most of the workpiece should be shaped by other processes to speed production. Variations may occur depending upon humidity and temperature. Then computerized designs must be converted to a format compatible with the photochemical artwork. Until now we have seen the chemical machining. Right? Now if you want to increase the production rate, I can say, or your machining rate, then we can add one new component to it, electricity, right? Or heating, we can say. What is done in electrochemical machining is it uses an electrolyte and electrical current to ionize and remove metal ions. You must have heard of the catalysts. Huh? What is the work of the catalyst is to increase the rate of uh, reaction or process, we can say. So here the electrical current is acting as a catalyst, and most of the work is done by here either chemical, right? But it is supplementing the rate of the machining. It can machine complex cavities in high strength materials also, right? And leaves a burr free surface, no affected by the strength, hardness or toughness of the material, right? As far as the chemical, it should be chemically reactable, we can say. The material should be chemically reactable, then only the machining will take place. And this process is, we can say that it is the reverse of the electroplating process, where there is a deposition of the material, or just like you are galvanizing or yeah, we, uh, plating of the gold plating like that. Yes, that type of thing. That is so. In this, in electroplating, we are depositing. Here it is. We are removing the material from that surface. In electroplating also, the material gets mm, deposited on one of the surfaces, hmm? And so it must be removing from the some other surfaces. That's why some otherwise material will not come from the outside. It has to be. It is basically it is transfer of the material. So we are just using that technology. So what we are doing is we are changing the, we can say, anode and the cathode. Polarity we are changing. Now we have put the, where we are putting the, uh, we can say, the job or the workpiece. Now we are putting over there the tool. Tool and the workpiece polarities are reversed in this process. Okay, let us see the one of the clips. Must be there, I think. Teaching. Yeah, this is there. Electrochemical machining. Let us see the clipping. This clipping is made by some South person, I think, in local language also. So this would be beneficial for, maybe it may be beneficial for our Vijayawada college, like that. क्या अभी जुड़े हुए हैं? वहां पर भी इतना साफ पहुंच रहा होगा ना ट्रांसमिशन सही. अभी के सिर्फ विजयवाड़ा सेंटर है ना बस.
Yes, sir. Art engineering. Vijayawada है as well as art. Yeah.
Okay, friends. So we have seen the various non-conventional machining processes. Though I was not able to cover all the processes, but uh, during this course you will be coming across all the processes in detail, which are uh, being covered by the various lectures given by experts, which will be coming after this uh, now onward sessions. In this 4-day, 5-day program, we will be covering all the processes one by one. So with this, I think we can break for the lunch. And before going for the lunch, earlier we started with, as there was no connectivity with the other centers. Now I would like to welcome the centers over there. We have with us RD College, Engineering College, Ghaziabad with us. I welcome you, all the participants of the RD Engineering College for this course. Thank you for very much for joining this course and showing your interest in this course. I would also like to welcome PP Siddhartha Institute of Technology, Vijayawada, for this course. Can you please? Yeah. I think now we are getting Vijayawada.
Good afternoon, sir.
Good afternoon, madam. Yeah.
Sir, I have a small doubt on water jet machining.
On water jet machining?
Yes, sir.
Yeah.
Sir, is the same machine can be useful for machining glass and tire?
Yes.
If what is the pressure we need to maintain?
Yes, what parameters you have to control actually.
Okay.
Depending upon the strength of the material and the ductility, brittleness of the material, you have to change the parameters actually. So
thank you, sir.
Yes, it would be very specific for that particular material. So I think we cannot generalize it like that. So it would be difficult to discuss here. Thank you.
Thank you, sir.
As far as this slides and all videos were there, were they clear?
Yes, sir. Very
Okay.
clear, sir. Can we get these videos and your PPT, sir? So that we can.
How to share? Let me try how to share it. Okay, we'll try to mail it.
Okay,
right?
Thank you, sir.
One more thing with the centers, you please send your attendances. We will be displaying you the uh, our email IDs now, and you please give us the name of the your faculty members who are attending the course over there, RD and PP Siddhartha College. I hope you would be able to make the attendance,
Yes, sir. We are
the list of the participants over there.
Yes, sir.
Can you please send us the soft copy also, right?
Yes, sir.
Uh,
Sure.
so, yeah, please send the signed soft copy also.
Yes.
Yes, not the typed one, the doc component. Right?
Okay.
Instead of sending it PDF or JPEG like that, please send us the soft copy also, right? And today we have a lecture at 2 o'clock by our expert Professor Manna from Punjab Engineering College. So, I expect that you all will be there by 2 o'clock, and we have a sufficient time of 1 hour, more than 1 hour, and with this we break for the lunch. Thank you very much for being with us. Thank you. Break कर दो.
ठीक है. हेलो, गुड आफ्टरनून पार्टिसिपेंट्स. उनके जुड़ गए? दोनों जुड़ गए? अच्छा अच्छा, मैं स्टार्ट करता हूँ फिर. अच्छा, गुड आफ्टरनून पार्टिसिपेंट्स. टुडे वी हैव एक्सपर्ट ऑन दिस टॉपिक, एडवांस मैन्युफैक्चरिंग मेथड्स, दैट इज प्रोफेसर Alakesh Manna. He is professor and head in the mechanical engineering department of Peck University College of Technology, Chandigarh. So he is having vast experience in the area of advanced manufacturing methods. So today he will be delivering lecture on the topic, the advanced non-conventional and laser beam machining topic. Okay, thank you. So please.
Achha, very good afternoon. Am I hearing, please? Yes. Okay. So the afternoon session are actually a bad session for the everybody's. Though I am trying my best level to do something that will help practically in teaching and other purpose. So this is a course of, I think it is a development course of the advanced manufacturing technology. Okay. So now myself is actually spent in the industry 18 years about in the Indian Railways and Indian Ordnance Factory through IES engineering service, and after that I joined through UPSC as a professor in the Department of Mechanical Engineering, and here I have completed 12 years of service. Now I have write 2 books, 10 PhD students have guided, 25 ME students have guided, published 216 research papers in the international national journals and conference proceeding last 14 years, because before I was not associated with the research activities. So anyhow, and I have awarded several times many gold medals and others, university gold medals, journal best paper awards, and best research paper awards of the Professor Trikha awards also I have received. And many projects within these 12 years I have also completed. Now I want to share something over here. Even during my journey of service, I have also completed charter accountant, that is equivalent course of ICW inter and final I have passed in the year of 1994 and 96. Once I was in railway official. So that was once a story of that time, because accounts people told you people are the technical people, you people have no any idea or about a knowledge of the accounts. So now heart of that time, and I tried to do it. Initially I went to the charter accountant office and they people told me, you are a government officials, you cannot take the registration attached with the audit firm. So then I went to this ICW, Indian Cost and Works Accountant of India. That is a professional course and very difficult to pass out. There are 50% pass marks. Marks are required to pass. There I have passed the inter and final of the accountancy. That is Indian Institute of Cost and Works Accountant. That is also very much important thing today, because what I am telling you, say engineers we can do anything if we want. That is one of the important thing I can tell you. So here my topic is, this is my brief note. Now my topic about here is advanced non-conventional. The Professor Rao request me, sir, you are coming here to for this deliver the lectures. And in fact yesterday evening I have seen this is his email. Once he called me, but after that we could not confirm. And evening when I, after the lecture of and others thing, evening I have also conducted some of the classes of the PhD student. And after that I find this is. So even I have not gone through the what about in this slide, many things. But something which we have that is very useful for you peoples. Okay. So now what are the importance what I am going to telling about over here. So the importance is basically, you see, in engineering industries, even equipment and designers are basic importance is high strength, high heat resistance, high hardness, erosion resistance and extraordinary properties of material, that erosion, corrosion, whatever may be this, that material we are looking in this view, so that we can utilize the different advanced material to fulfill our desire or to fulfill our aim, which will be required in future and today requirement by the industries. Even the complex 3D components, so that is, say, you can say turbine blades, that is also a challenge today. Even this is become manufacturing, because today turbine blades are also manufacturing not only monolithic materials but also manufacturing from the some plastic polymers and even some ceramic materials. Now the ceramic, plastic, polymers machining are very difficult because of the lot of problems. That's why that is a resistance widespread application in the various industries. So we have to solve, that is the challenge today. We have to solve how we can, the machining can make into the complicated shape in the your utilizing some of the machining infrastructure, some of the design infrastructure that here need to be developed. Now another, the miniature features which is become very important, that is, I have given over here examples, filters having few tens of micrometers as hole diameters and thousands in number. That is in micron level of the holes, in thousand numbers in a basic platforms, which the platforms are of materials which are the not corroded, pitted and rusted by any of the environment. So that is not only, again it is not possible on the monolithic or which are become the commercially available materials. So some of the advanced material we have to be again used for utilize such kind of these filters. Even miniature holes in diamond dies for wire drawing operations. Just like you can see, say it is a E-glass fiber epoxy composite, S-glass fiber epoxy composite. If you want to manufacture of such kind of composites, you will be a first manufacture a very good die of in nano or micro level in dimensions of hole. That is usually 7 holes or 7 microns, 7 to 9 microns meter of diameter holes. You have to process a gel which is become a chemicals, that is your alcohols and as well as the sand particles. You have to process through this and you have make the fibers and you put into the fiber into the plastic, so you can make into a E-glass fiber epoxy composites. So this is the challenge today. We have to manufacturing of such kind of things. Then turbine blades holes are also in importance. Another, the nano level surface finish, that is also another important aspects which is become your you can say it is a challenge also today. Thousands of you can say turbulated cooling holes in the turbine blades. Not only that, today we are complex engines, that is of the lubricating oil in the big hole or big end bearing with the crankshaft. So that is also required to clean inside the surface, which is so called it is a blind hole. That is challenge also. Making and finish of microfluidic channels is a micro channels in the electrically conductive and non-conductive materials. I have just told you. So glass, quartz and various ceramics, various epoxy composites, these are the really difficult to machining, even cleaning. Because of non-conductive material, you cannot the remove material by well-known conventional, even non-conventional machining process. If you use the conventional machining process, micron level is very difficult to use any machine or even tool. Manufacturing of the tool in the micron level is also challenge. Same thing in non-conventional machining. If you're talking about this, say electrical discharge machine, wire electrical discharge machine, electrochemical machining or chemical machining process are not also help you to cut the non-conductive material, because of the once you use at anode, it will not be response by chemical when in electrical your dissolutions, or even it is the electrical conductivity even not possible to bombardment of the electrons from the outer orbits or outer surface of the anodes. Clear? So that's why it is impossible to cutting by the well-known machining process of non-conventional. So what are the solutions? I am coming here. So it is a purely research based, because once he has told this is the faculties are coming, so I am very much interested about it, otherwise I have to refuse it. So now I am telling you over here some micro fabrication by advanced machining process. So now I am showing over here some pictures. You see, say electrodes here. This is the electrodes. You see that electrodes we will use for making simple. This is the electrodes. You see what are the fins? You see very thin fins. That electrodes will use to make this particular die cavity. So, अच्छा माउस अच्छा इसमें Acha, this is okay. So this is become, you can say, this is a really difficult to manufacture fast, to make into this type of thing. Then you can see, and then you can make into the replica of this, just like you see the pattern and casting. So similar way we can make into this. For this purpose, if it is a conductive material, then you can use the electrical discharge machine. If it is a non-conductive, ceramics, polymers, and even many things, gallium nitride and many things of the semiconductor materials also very difficult to cutting. Even, you know, here, this is a materials of cooling channel, is a cooling channel and a hole of micrometer, only 50 microns. 50 microns of hole making into the channel. So this is a very difficult to manufacture. That's why. Next you see, so it is a simple injection molding process for watch casting process. But molding process is not a process for faster and mass production process. Because of, you know, this is a simple, I am showing over a simple watch. This simple watch of made of plastic. Market, that is, you can, you identify, that is usually sell into the market 30 rupees, 25 to 30 rupees. Therefore you can guess what is the manufacturing cost of this particular your watch. The manufacturing cost should not be your the 40% of the total sale price. So that means, you know, if it is a 30 rupees is the sale price, then you can easily understood. So yeah, what is the manufacturing cost? You only 12 rupees of this. Now then your others marketing cost, sales cost, brokerage cost, and all these are there, and then profit. So therefore we have to make and take care of these very small different holes where we have to put the your micro gears and all these. That is also challenge on the your polymer or plastic materials to make into this. Second thing is, you see here another, this is become a punch die. That is also can possible to manufacture. This is a, you see, make a groove on this particular use as like as a gaskets, and this is become very micro teeth on this. This is also can possible to buy EDM. If it is become a, again I am telling it is a conductive material. If you want to make it is by the ceramic materials, it is very difficult again to manufacturing. So similarly, extrusion die also I have showing over here. This is extrusion die. You can see how it is become the shape of these. So these are become one or two examples just I am showing over here. Another, you see, micro machining by EDM. So EDM process we can use for machining of the micro holes. You see here one thing is important. Here this is become a inkjet printer. Inkjet printer, where we have to use simple printing. That printing having a here, you know, 24 your hole. So there, if you want to make a hole, what is the materials? Material is inox. What is inox? Now this has become another important thing, that you are engineers. You should only know the process, not that. You have to very clear idea about the materials as well as. Then you can control the over material. That means, say very simple example I can quote it over here. So mother can best to control her child, because mother knows what is the refractiveness in the child, how the child and at what time expected behavior can be. So similarly, you are become the engineers, you must have to be a wide and versatility over the knowledge about the properties of the various materials, and what and when that properties will become in favor of the manufacturing process and against the manufacturing process of this particular material, and accordingly you will become set up, then you can overcome and you can overrule on this particular material. That is the basic idea of this your manufacturing or advanced manufacturing process. Say just I am telling you, refractory means, you know, say today usually you people have many of the, you are now the fathers, I think, father of a child. So then sometimes child will become returned back from his school or from his college in the late. Now father returned back from the office shouting on his wife, and after that taking his food and going for sleeping. Now in the meantime child have returned back to the your home. Now the mother telling, where you are, your father is shouting on me and this, that. Then after that the child also, no, I will not take the food and go to his room. Now mother is very awkward situation because of child have not taken their food and all these, mother frequently calling, beta come here or Betty come here, you please take your food, and then we go, I am also not taking the food and all these things. So then beta or Betty, whatever may be the thinking, yes, this time, next time mother call me, definitely I will go and take my food. But when the mother called, yes, beta come here, immediately, no, I will not take my food. So meaning is this, meaning is the refractoriness. So somewhere that refractoriness, yes, next time call, then I will go. But once call, no, I am not going and I will not take the food. So this has become the characteristics of the human beings today, child. Similarly, the materials are become the search of characteristics, and that characteristics we have to utilize. Just like I am telling you, the manganese steel. Manganese steel have a very good characteristics in favor of wear resistance. That is a so-called known as the your refractoriness. How? Say once you cut once, you can cut once, but second time you cannot cut the manganese steel. That's why manganese steel are usually recommended for manufacturing of the liners. So whatever may be the depth of cut you want to put, you have to give once. Otherwise you put the depth of cut second times. If you use the shaping machine, if you use the slotting machine, you understand? This is a slotting machine and this is a shaping machine. Or otherwise you can use any of the processes. You want to cut by the single point cutting tool is very difficult to cut it. Rather, cutting tool will become worn out very fastly or very quickly. Tool life will become reduces because of the refractiveness of the manganese steel. So this is become the important thing. You have to be understand what are the material, what are their characteristics, how you will become handle and how overrule these properties to make in accordingly you want to desire to make it. Understand? This is very much important to the challenge. So here, what I am telling, the inox. Inox is your chromium steel, 12% chromium and 0.65% of carbon only. That was the earliest used. Until 24 pin of printer, inkjet printer are made of inox material, chromium steel. But today you are using the polymer, plastics. So how you make this micro hole on it? If you make the conventional machining, it will become micro crack developed on it because of brittleness of the plastic and ceramic materials. Because of the brittleness, the micro crack once will become used, it will become developed into the macro levels and cause of failure. So here you see, this is your micro electrodes material, tungsten copper, diameter only 20 microns. So this is micro tools you see here. This is a micro tools. This is, you see, and how it is become make this micro hole. So this is also today challenge. Anyhow, I am coming again to the fabrication of product. Now what are the fabrication of product process usually? Usually process liquid phase approach, solid phase approach and two phase approach. We have a three approaches. Liquid phase approach, just like you know, today's composite materials are manufacturing by liquid stirring method. What is liquid stirring method? So you first melt the matrix material, then you put on the matrix material reinforcement with agitated at a certain temperature for several hours, 2 to 3 hours, then put into the ladle where you put the matrix material. So matrix may be aluminum, may be magnesium. Again magnesium melting is a challenge. I think you people have an idea very clearly. Huh? So once you going to again to this, put into this, then what are the melting points of the matrix material? What are the melting points of the reinforced material? That is again a very good challenge today. Because of if you don't know, that is very difficult to maintaining over there. So let us you consider it is become aluminium, is a matrix material, you melt it, 660 degrees centigrade is the melting point. You put into a furnace, you maintain 700 degrees, 710 degree plus minus 5 degree, then it is melted easily. Then you put, say let us silicon carbide. Clear? Now you put the silicon carbide agitated to 1150 or 1250 degrees centigrade for 2-3 hours. Then you put into this, because they are melting point 2750 degrees centigrade. Now you stir properly. Then you put into the prepared cavity. That's why it is so called the liquid phase approach. This is a liquid state, then put into the prepared cavity, then allow for solidification, then you make into the appropriate design of casting materials. Clear? So it is all right, as like as a conventional casting process. But what I am talking about the micro casting process. When I talking about the micro or miniature small parts, how we will become manufacturing with this? This is also today challenge. You understand how? Say let us, it is a wafer. What is wafer? Wafer fabrication, again it is a challenge. It is nothing but that if I am making a potato chips, simple, not make of potato. It is made of any advanced material which has so-called designated as a smart material. Only extensive stimulation, its properties become automatically changed. What is the stimulation? Stimulation is by changing the atmosphere, by changing the temperature, by changing your pressure, that automatically changes their properties, whether extended, whether contract, or whether liberates the electrons from the surfaces. Now I want to this wafer striking by the electrons on the surfaces. I want to energize on the surface to overcome the work function, so that can electrons liberate from the surface. That is wafer fabrication. So that I want to, by making on the drop wise of a molten metal on this drop, is a micron level drops on the surface of the wafer to deposit. That is bottom up approach. Another is the top down approach. I think understand. Top down approach is nothing but that removal of the materials from blank. So maybe I want to turning of diameter of say 50 millimeter. I want to need the 48.5 millimeter. So that I have to remove 1.5 millimeter on the diameter. So I have to remove by using a single point cutting tool, left hand or right hand, whatever may be the case. I used into the chalk and dead stock support, and I can remove it. Material. This is known as the bottom down approach to remove this material. But once I talking about the micro dropping with the laser beam, or otherwise with the melting of the material, or by the particles of metal powders with the injection of the laser or electron beam drop, this is microcasting to bottom down approach. And once I approach it, so that I can make what dimensions and what are the properties I need. Because I want to put some semiconductors, I want to put some, so you're just like you can say lithium, magnesium, a lot of things I want to put on it. Even I want to some micro small parts, I want to solid lubricants, say molybdenum sulfide. It is a ceramic, good ceramic materials, but good solid lubricants. I want to make a very good layer on the surfaces. Clear? So that type of phases are so called liquid and bottom up approach to make into the desired micron level thickness on this particular wafer, and that wafer will become again further reuse after their lifespan is. You can calculate the lifespan based on the material deposited, based on the layer deposited, based on the thickness of the layer. Second is solid phase approach. Solid phase approach, you can show this is powder metallurgy process. You will, I think, read it. So that powder metallurgy process is nothing but that here you first make into the metal powders. Different processes are there. Different processes. If you want to make a metal, now this is a solid metal, I want to make a metal powder. If it is conducting or not conducting, first you become identified. If it is a conducting material, if I connected with this electrical circuit and I connected with the another, it is a, I have given some rotary motion and I connected with the another your tungsten electrode or fixed, not rotating. Maintain a small gap, supply the current, so that what will happen due to potential difference, it will started sparking and it will be rotating. Started sparking, you maintain the gap, so according to the copper loss, that is I square RT, so heat will become generated, it will start to melt and you rotate in this atmosphere of a complete inert gas. then can metal powder become easily manufactured. That is known as rotary electrode automation process. So a lot of the process advanced today, and that we have to use to make the solid phase approach. So that in the solid state, I first make into the nano level metal powders in the form of powders, and then I go for this your blending. Blending means it is a heating and homogenizing of the metal powder. I want to put some of the compositions of the metal, different composition of the metal together and getting the best way. Then you mix together and then you heating and compacting. New pin rubber pad you will use, very good rubber pad you put on the rubber pad and then put into a particular die for making into a even 1 millimeter of gear. You can make this 1 millimeter of gear, spar gear, spiral gear you want to manufacture. Very difficult to manufacture by any conventional process. So this is known as solid phase approach. Another is two-phase approach. Sometimes, just I have given you one of the examples, solid base, I put the liquid. Clear? Or liquid phase, I put the solid fibers, whiskers, platelets. This is lot of things I can put inside this, I can make into this. Anyhow, common fabrication process I have given here, you know everything, casting, patternology, forming, machining, welding, assembly and all these. These have become the common things, I am not interested to this. Now again, what is advanced manufacturing process or advanced fabrication? Advanced fabrication, you know, here I have given two things, at the macro and another is the micro fabrication. You know, the macro fabrication is the process of fabrication of structures, parts and products that are measurable by the naked eye. That is macro. You can measure, you can see your hair, that is dimensions about 1 millimeter of diameter. But very less you cannot see even a naked eye. So that is micro fabrication. The fabrication is a miniature structure, parts, product which are not easily measurable by the naked eye, which is less than the 999 micrometer of size. Clear? So when it is dimension is very less, it is very difficult to measure and very difficult to also the manufacture. Now I am coming to this entirely into the machining. That is the basic introduction what I am telling, what are the importance that I am now going to this actual machining process. That definition I have given in my book, a textbook of manufacturing science and technology. This definition I have taken from my book. This is picture and definition you see here. The machining is an essential process of semi-finishing or finishing by which jobs of desired shape and dimensions are produced by removing extra material from the blanks or work material in the form of chips with the help of cutting tools move past the work surface in the machine tools. Everything I will include within this definition. Clear? What I have put over here, it is an essential process for semi-finishing or maybe finishing. May not be finish is required. May require to remove some extra material from the blank. Clear? To make the desired shape and dimensions by removing of extra material from the blank or workpiece material in the form of chips with the help of cutting tools move past over the workpiece surface in a machine tool. So everything is becoming completed over here. I am showing the very simple thing from diagram you can easily understood. Now this is machining. Now the non-traditional machining. That is actually the topic I entered over here. What is non-traditional machining? Non-traditional machining process refer to processes in which non-traditional energy transfer mechanism and non-traditional media for energy transfer are involved. What are the media? How you transfer the energy? Clear? So this is the important thing. If the non-conducting material are not possible to cut by electrical discharge machining, so that means what type of machining methods are required to introduce or develop so that can I cut the ceramics, composites, polymers, polyethylenes, nylons, because these are the under some categories of non-conductive or very poor conductive. So the non-traditional machining includes the electrical discharge machine, electrochemical machining, laser beam machining, abrasive water jet machining, wire electrical discharge machining process, ion beam machining process, abrasive flow machining process and lot of things. Though I am not written over here any hybrid machining process. I think understand. What is hybrid? जो हाइब्रिड अच्छा होता है, बोला ना भाई मार्केट में आप व्हेन यू गोइंग टू इन द मार्केट टू परचेज समथिंग, दिस प्लांट इज हाइब्रिड प्लांट। क्या है भाई, ब्रिंजल होगा तो इतना बड़ा ब्रिंजल होगा, बढ़िया होगा, वेरी you can say it is not only 1 2, it is more number of brinjals can be coming from this particular plant because of it is hybriding. Similarly, we have to identify some hybriding processes, hybrid process. That hybrid process can help to cut any sort of material, irrespective of their conductivity, irrespective of their hardness, irrespective of their insulation or insulator. So I am just showing some of this research work so that you people will understand so how it is important today's to developing of such thing. So non-traditional machining processes can machine precision components from sophisticated material. They offer the advantages of a reduced number of machining steps and a higher product quality. And non-traditional machining can also exist within the domain of automated production. Obviously, there have a automated circuit board, automated switch, and automatic input some program can work. Interest in non-traditional machining has been on rise due to increasing of interest in the vastly superior properties of the innovative materials. Just I am just telling, super alloys, composites, and ceramics. Non-traditional machining offers an attractive alternatives and often the only choice for the processing of these materials, and the new and potential applications require enhanced process capabilities and more precise process design and optimization capabilities. Optimization, I think you people have understand. So optimization means, so that is, you see two things here: productivity, increase the production, optimization. Productivity is increase the production without increase the input energies. Or simple increase the production may increase the input, can increase or can enhance. But optimization is nothing but that it is a technique. By utilizing some of the methods or processes or techniques to improve the quality of the production, reduces the input, arrest the nonsense parameter or nuisance parameter, or otherwise arrest or save again the your environmental activities, or otherwise non-controllable parameter activities. Some of the parameters are non-controllable but can arrest. So these are become the important things which have been required today's. Now non-traditional and traditional machining comparison. What are the, how you comprise between two things? So non-traditional machining like laser beam machining process transport photon energy into the target materials in the form of thermal energy or photochemical energy. They remove material by melting and blow away or by direct vaporization or ablations. What is ablation process? What is your vaporization process? What is chemical vapor deposition process? What is vapor deposition process? So lot of things are the question arise over here. Boring Phil? Are you boring?
No, sir. Interesting.
Because this session is a really not good for health. Everybody is going to the sleep after taking a food. That is quite natural phenomena. This is quite natural phenomena.
No, sir. This time, बहुत ज़्यादा energy लगानी पड़ी इस सोचने के लिए.
Now, once I listening the Professor Rao told me, he's very close to me. He told me, sir, the teachers are coming. So I'm so that least then, though I have no time, actually, really I am telling you. Today morning I have delivered 2 lectures. Even 11 to 12, one of the lectures. In the meantime, your decks, your auto decks, they people will come. They people will come exactly 12:10. And I in my office. And then they people started to discuss. I leave my office is 1:10. You can to go my home and immediate take the food, and again immediate rush to the over here. And yesterday evening when I sitting, I see, and we have certain, because we have a PowerPoint about more than 150 PowerPoints and the different aspects. You know, I think delivered a lot of places in the different areas, not only India, outside also I went several times for delivering the lectures. People have called me in different aspects and different areas. So that I have some preparation ready-made. That's why I told you anytime you can call me, but I never think you call me Monday. I think might be another one today we have, then we have. And I have a lecture again in the 4 p.m. in our third semester student. Though I put... Huh? Huh? Something to available hai. I can give you something, many things is available. But something latest, here something latest research, that's why I am not given you to the net. Some research I will show you in the last of few slides, that you will understand, because you people are teacher, you people have a student always. Every sort of student, you have a PhD student, you have a ME student, you have a BTech project student, you can utilize a lot of things, you can improve student and yourself as you want. Clear or not? So that's why I am telling you, it's a lot of things with me. Even nothing will require. But once we am going to for a fight, I have to prepare my sword. That is quite natural. Otherwise, you will not fight properly. That is fact. So, anyhow, so you don't demoralize, you should try to listening. If you any queries, you can ask me, that is not a problem. Just I have given you another example, see people. Say, simple bearing materials. What is bearing materials? Simple I am asking, very simple. What is material? What material you can say it is a bearing material? Bearing liner. Lining material, कौन सा material हो सकता है? Copper zinc alloy bearing material. ना, copper never used as a bearing material. Copper का melting point 1083 degree centigrade, 1083 degree centigrade. Because we should have to be choose. मेरा ये जो ब्रेन है ना, हेड बड़ा छोटा है, बट ये फंक्शनिंग एज लाइक एज डिक्शनरी, एकदम 100% डिक्शनरी. मैं चैलेंज करता हूं किसी का साथ, इट इज 100% डिक्शनरी. जस्ट आई एम गिवन यू वन थिंग एग्जांपल्स. से व्हाट वी आर यूजिंग, यूजुअली स्टील सेल bearing. Clear? We need some lining inside this. Clear? So the lining material should be such a material which having a low melting point and good ductile. Copper is a ductile but high melting point and very costly. Second thing, it is a very good conductivity, electrical. Once the rubbing and friction, due to rubbing friction in the rotary parts, so like armature का ऊपर अगर आपने copper lining दे दिया, what it will function? It will behave because of due to rotary movement, the induction takes places, cuts of lines of force. Understand? So that magnetic flux linkage will produce. And magnetic flux linkage, that is phi, which is directly proportional to the I current produced in eddy current produced inside the bearing, which will be helped to the wear out of the materials. So that's why we never recommended the copper material as a bearing material. Understand? Second thing, so then what is the bearing material? Bearing material is white metal, that is beveled metal. नाम सुना होगा आप लोग? Yes. Now the beveled metal, now I am telling you, ये मैं डिस्कस कर रहा हूँ, आप लोग को थोड़ा देखा, दो एक बंदे का नींद आ गया, ये मैं देखा, so that is the what will be the fruitful for us. So that's why I am just switch over something else discussion. So then, what is the composition? What are the composition of the white metal, that is beveled metal? What are the materials? क्या क्या material उसमें होना चाहिए? Have you a simple idea है आपका पास? Don't worry, dear, prestige का matter नहीं है, यहाँ हम लोग तो discussion कर रहे हैं. Everybody are, I have some area is the versatility. You have a other area versatility. I don't know, because there is no scope to discuss all this. You have a definitely some area you are far better than me. So that is not at all of things we are discussing over here. So here, three components. One is the tin, lead, and antimony. Three materials are usually used for manufacturing of the babbitt metal. Antimony. Tin, lead and antimony. Now the question is, very simple thing, जे सर आपने 3 मटेरियल, तो 3 मटेरियल कैसे आप मिक्सचर करके उसको व्हाइट मेटल आप बनाओगे? That is a challenge again. Then you require the knowledge. What are the knowledge? First, what is physical properties? अगर कोई बच्चा पूछे सर फिजिकल प्रॉपर्टीज क्या है, हमको समझ में नहीं आता है, तो हाउ यू विल सेटिस्फाई द स्टूडेंट? फिजिकल प्रॉपर्टीज आर जैसे appearance, density, temperature. These all are the physical, not mechanical properties. Mechanical properties just like a hardness, toughness, strength, ductility, malleability, elongation, and all these are become the mechanical properties. Clear? So now the question is, once I am going to the manufacturing of this particular white metal, we need the your everything properties you should know. जो पहले मैंने अभी बताया, जी we need the all properties knowledge. So what is the melting point of tin? 232 degrees centigrade only. 232 degrees centigrade. What is the melting point of your antimony? No. I have just told you, we have to use the bearing material is low melting point. Not that, not more than that of the lower critical temperature of the low carbon steel. What is the lower critical temperature? No, 710, 723 degrees centigrade. So this is become the very much important, you know, first. Clear, understand? So not beyond that. So therefore, antimony must have that the below temperature of melting point. 630 degrees centigrade. Now the melting point of lead. lead तो एवरी घर में यूज होता है, यूजुअली यू नो प्रेशर कुकर. प्रेशर कुकर में जो फ्यूजिबल प्लग सेफ्टी वाल्व दैट इज मेड ऑफ lead material. 327 degrees centigrade. Only 327 degrees centigrade. There you can make yourself engineers. ये ब्रेन ऐसा है ना, ये काम करेगा डिक्शनरी का माफिक. Then you can guide your whatever maybe you need. अच्छा, not only that, now this is only the not enough. Melting point is enough. Other thing is also enough. Densities. What are the density of the 3 materials? Then you can put 3 together in a furnace and you decide the furnace temperature. Then you can know what type of steering mechanism are required to make into a very good homogenizing before making into the babbitt metal. Clear or not? So what is the density? Which one is heavier, tin or lead, or tin or antimony? First बताइए. Which one is heavier? Whether tin heavier or antimony heavier? No sir. Antimony is not heavier. 6.69 gram per cc antimony. 6.69 gram per cc. Our tin is 7.2 gram per cc. Understand? Tin is heavier than antimony. रह गया your lead. What is the density of lead? 11.32 gram per cc. 11.32 gram per cc. That means your brain should work in such a way so that operator, technician, student, yes, you can match with the book anytime. You have noted, I think, you match it. Then you will understand. Now you can decide what are the type of the furnace you can decide for this particular material. Melting first. Then you, that molten metal, how you identify or select actual and appropriate volume of the product. That is optimization. Appropriate volume. Otherwise, आप ज़्यादा volume ले लिया material during melting condition at elevated hot temperature. You put somewhere in the centrifugal casting because you make into a drum type, cylindrical, oxysymmetric type of product. Then you place inside the bearing. Clear or not? That is a liner, bearing liner. Then you need the centrifugal casting process. Then how we will become taking the volume? Another important point also here. Furnace temperature before deciding this, tin to only 232 degrees centigrade. So what is the vaporization temperature of tin? Because of 630 degree again antimony ka melting point. Then if you want to make the melting of the antimony, in the meantime tin might be vaporized. Then the percentage to आपका loss हो जाएगा tin का. You cannot maintain the composition and properties. So furnace temperature decide is another important or optimization again. Otherwise आप furnace temperature बढ़ा दिया 632, okay यार 650 कर दो furnace temperature. Then तो आप tin भी in the meantime गायब हो गया, सब tin नहीं है. What is the vaporization temperature? 480 degrees centigrade. Started to vaporize. Then we have to decide the furnace temperature should be around 480 plus minus 5 degree. So that can protect against the vaporization of the tin and as well as agitation of the antimony. Lead can melt 327, nothing will be a problem. Now the how will become mixed, homogenizing, weightability, good weightability of the antimony within this molten tin. Then you can make the otherwise blowhole will appear. Blowhole, blind hole inside the casting of the liner. Because liner thickness, you know, the 1/16 inch, that is 1.6 millimeter of liner thickness. It is a challenge. Again, you have to manufacturing of the liner thickness of this, of a drum. Very common the phenomena in the manufacturing scenario. Understand or not? Now I am not talking about the machining. This is only one of the simple casting process. So what furnace you will decide? कौन सा furnace आपको decide करना चाहिए? कौन सा fuel होना चाहिए so that can maintain this temperature? Now the question optimization I am just telling you. After that I will coming over here, because it is now I think you will have energized. So you can recommend a oil furnace. What type of oil you will use? Use transformer oil. Transformer के लिए जो cooling oil use होता है, cooling purpose. After cooling you collect this oil and just keep in a certain height in a tank and automatically it will sediment deposited. You taken from the siphon system from the top in the gravity action. Put a nozzle with a inject of air, compressed air. Use transformer oil. Understand? So this is the scenario and today need the manufacturing to improve the productivity. Understand? So one of the just example I have just shared with you people. Now advanced machining process, again I am come back to the over here. I think now it is well. Can come back, sir? Okay. So advanced machining processes here. Advanced macro, micro and nano. This is three things, again three categories. Nano finishing, macro machining and micro machining. I have already explained macro and micro. Advanced micro machining process can be classified. Again, how you classified this? Mechanical force apply for removing of material in the form of macro or nano or micro or nano chips is known as mechanical micro machining. In the form of nano chips, you cannot see in the naked eye. And utilization of direct energy, whether beam, electron beam or otherwise plasma, laser, you can use. Now the question is, what is plasma? Again, what is the temperature you can generate in the plasma? Understand? Plasma is nothing but just I given you simple example. Nitrogen is a plasma gas and shielding gases are oxygen, carbon monoxide you can use. Clear? Even sometimes hydrogen also you can use. So if you nitrogen gas will become, rise the temperature 2000 degrees centigrade. So atom is liberated from the molecules. Some of the, not all. You further rises the temperature again 3000 degrees centigrade. Then it will become, some of the electrons are emitted from the atom. Clear? And it will become tremendously ionized and passes through a nozzle, orifice, whatever may. This is plasma, nothing is to be more. Now you have to control it. How to become, you help to process it. What type of orifice, what material you will use, and how to excite it and passes through this, striking on a particular material, so that is all right. Nothing. Clear? So this is the basic thing of the plasma. रूबी रॉड बोलता है उसको, लेजर में रूबी जैसे यूज करते हैं, जैसे आप टंगस्टन यूज कर लिया, टंगस्टन कार्बाइड का मेल्टिंग पॉइंट कितना है? This, that's why I again come back to this, because of plasma. I have just telling you 3000 degrees centigrade, so then must have greater than 3000. Otherwise, once the liberate the electrons, till liberate the holes, because in opposite direction have required to move, then make a plasma channel. Till it is not make a plasma channel with helping some atmosphere, it will become harmful to the metal, which will become generating and creating. बात आप समझ में है? So that temperature should be more than this. 3350, 3350, diamond 36. Understand or not? So that type of material we can use that to generate, and this particular atmosphere which will become effect to absorb or dissipate. Clear? Both the way can function, whether anode or whether cathode. मैं just like गया था tungsten cathode without rotary motion, when we are giving an example for manufacturing of the metal powders, है ना? So that's why we are using the tungsten. Otherwise, ruby rod is usually used for the laser generation. Their temperature is more, 6600 degrees centigrade. Their highest temperature will generate it. But we have to make their protons and your electrons both are become the movement in the opposite directions. Ion beam, laser beam, and electron beam. I think you understand. According to the name, it will become movement of this electron, proton, and ion. So, electrochemical and chemical reaction for removal of material is known as chemical and electrochemical machining. This is very simple example I am showing over here. So this is the correlate with the all the your, you can say the, here I want to show you one thing is important. Here you see thermal process. This is a thermal process, this is mechanical process, and this is chemical and electrochemical process. Thermal process, electron beam process, plasma beam process, laser beam process, electrical discharge process. Clear? Say electrical discharge process, you see electrical discharge machining process. What are there here? Electrons and ion both make a plasma channel. Understand or not? If you just analyze this electrical discharge machining process, you say very good plasma channel. Plasma channel, and here dielectric media will use. But if I am talking about the electrochemical process, electrochemical machining process, you see, that is will the electrolyte in place of dielectric. Because very simple definition, you know, there the electrical discharge machining process, the material is removed from the conductive material by conductive material only by rapid and repetitive discharge of spark. Clear? From the cathode, and material removed from the anode. Anode and cathode are separated by a dielectric media, thin film of dielectric media. But if you define the electrochemical machining process, again you can define, so that is material is removed from the electrically conductive material, same thing, by dissolution of the anode. dissolution of the anode separated by a thin film of electrolyte from the cathode. You understand what is the difference between things? This is only the difference. So that process gives you the details. What are these? Your workpiece media, energy carrier, and all these. From this you can easily chalk out what are the processes involved over here. Simple ECM, electrochemical machining process, pump, electrolyte, job, fixers, and tool. There is a electrical supply. Tool, you see, this is become your cathode, and negative terminal is connected with this. That's why it is cathode. That is so-called electrodes. And this is positive terminal connected with the workpiece. This is called anode, which we are interested to remove the material. Clear? Sometimes this is steam tube. This is hollow of electrode. We can send the electrolyte through the hollow. This is so-called steam tube type of electrochemical process. This is, that's why you see. And this is become a, the plasma channels here. Positive and negative ions, these are the reaction takes places, pH value. And this is, I am showing the different electrolytic dissolutions. This is your hydroxyl ions to your OH to water bubbles generated. Clear? Even sometimes I am asking some of the students I find, so that the water can you use for cutting of this material in electrical discharge or wire electrical? Yes, water can be used. Can be used to cut it. But what will happen ultimate? Material removal will become increase. We are electrode, our rate will become increase. And after initially, and after certain interval, it will become stop of functioning slightly and slowly. Why? Because of hydroxyl ion generated wound the wire or wound the electrode, which is become your non-conductive, not help to carrying the electrons. That is, plasma channel will become destroyed after certain intervals. So this is, you see, this is become striking tool and make a cutter on it. This is liquid, vapor, and plasma. This is a gap, tool and workpiece. This is a gap in between. This is known as spark gap, which is required a small gap to help to make into the sparking, so that can metal is removed. Rapid and repetitive spark. This is the basic thing, cross-sectional view of the simple your machining process. Now, sparking cycle, I think you know, this is I am showing over here. This is upward direction hole and electrons. This is a plasma channels, plus and minus. You see, this is open voltage. I am showing over here just overview. Overview I am showing over here. And usually, the duty cycle, it is a ratio of your pulse on plus pulse off divided by what is? You people are the mechanical engineers all mechanical engineers, na? That is pulse on divided by pulse off plus pulse on. याद रहेगा ना? And इसका unit है decibel, dB. Sometimes the students are very intelligent nowadays, because of students are getting from the net. They will asking, sir, what is your unit of you can say it is duty cycle, or sometimes कौन फोन कर रहा है? 1 minute just I can हेलो, हाँ मैं बाहर लेक्चर दे रहा हूँ, प्लीज आफ्टर दैट आई विल टॉक टू यू. So then here one thing is very much important. We have to silence कर दिया, our problem. So then you have to one thing. So then pulse on means sparking allow for how much microsecond? Simple, nothing is to be complicated. Then pulse on plus pulse off, that is a complete cycle. on and then off. Off is required because of removal of this material from this. Another important thing, just like electrochemical machining process, similar way, say usually we use the DC. Some question are students sometimes asking, why not use our AC? We teachers should know at least why we not use the AC. Because of DC have redox, means reduction and oxidization. Both the function takes places. But AC only conduction. If you conduction takes places, because of conduction, that is become half cycle is become peak and half cycle is bottom time. Immediately reverse. That's what is good conduction. If you conduction, whatever may be the heat will become generated, it will not bombardment or not striking on the surfaces, rather it will become carrying air. So metal will not or free the electrons from the surface. Cannot overcome the work function. Work function means it is a resistance amount of force or energy is required to overcome the bonding force or broken the bonding force between the molecule on the surface where you are striking the energies for removal of the material from the anode. So therefore, here one of the important things, so that the use of DC. Oxidization and reduction both takes places are required. Clear? So here one something I have just telling you, so that is maybe, say it is a usually coming, say value maybe, say it is a 0.6 of the parks on, or 0.3 may be off. So 0.6 by 0.6 plus 0.3, 0.9, so something again it is a point fraction. That means sometimes it is, you will get the value in terms of the decibel, whether it is a negative value, whether it is a positive value. If it is a positive value, so that will not lag behind, it is lag forward. If it is a positive value in the duty cycle. Or if it is a negative value, say negative 12 dB, that lag behind from the spark on. I think understand. So these are the very much important while you are going to analyzing, and if these characteristics you know proper way, then you can control such kind of machining methods. समझ में आया भाई? तो ये बड़ा important चीज है, आपको समझना पड़ेगा ये चीज. So then I can overrule over this particular machining. That is wire cut idiom. I am not interested. Another, this is different machining methods, different advanced machining methods. So here you know, ultrasonic machining methods, water jet machining methods, abrasive jet machining methods, chemical machining methods, electrochemical machining methods, you know, electro discharge, laser beam, electron beam, ion beam, plasma beam. These are very simple pictures I showing. So these are the different processes. Clear? So these processes, few of the processes we can use, even non-conductive material cutting, but sometimes that we also fail. Just like you cannot control the plasma beam, you cannot control the electron beam, you can control the ion beam, because of once if you put the nozzle, so nozzle it, you do striking like this way, it will become ultimately, if you maintain the standard distance between the workpiece and nozzle, this is known as the standard distance, and the distance if you very close, the striking energy will be less. If your distance will be more, energy will be more, but it will tapering effect because of divergent, not convergent at all. So this is also another important criteria to control and concentrate this part. That's why that type of machining methods will not recommended for your machining of micro levels. Micro levels machining is very difficult by of such kind of machining methods. So then we cannot recommended such kind of machining method for cutting of such materials of micro level or miniature parts. Clear? Just I am coming after that, you will see. Now this is become the different micro machining and nano finishing processes. What are the processes? You know, advanced micro machining processes, micro machining, micro or nano finishing process. Here you see one by one, you see different processes. Electron beam machine, laser beam, electrical discharge, ion beam, plasma beam machine. Photochemical micro machining. Photochemical micro machining. You understand? Electrochemical micro machining. You know, abrasive flow machining. Magneto abrasive finishing. Then you see magnetorheological abrasive flow finishing. So these have become this lot of processes. All are become known as the advanced. This is a hybrid machining process. Magnetorheological abrasive flow finishing process. We have to use some magnetic induction to control the particles of abrasive. If I use some your iron particles, that will become attracted by the magnetic inductions. We can accordingly we can control it in a path, and we can strike in a particular area in a small orifice to make the clean or something else. So this is so-called it is a hybrid process. Similarly, we have magnetorheological finishing, elastic emission machining. Elastic emission by striking of the balls. Just like you see, this is become a workpiece, and this is known as coupler. Coupler means some coupling of some heads on a ultrasonic machining. This is usually known as couplers, and the coupler is vibrating on it. You put inside there some of the abrasive particles. So abrasive particles is vibrating and striking on it. So it will strike on the workpiece, again bounce, strike and bounce, strike and bounce. So energy can transfer on the workpiece surfaces. Cause of catering. I will show the picture. How it is removed this material. If it is a ductile, if it is a brittle, how the material is removed from the surfaces. By coupler is become vibrating due to your, you can say it is a transducer. Use a transducer. What is transducer? Which is become, पहले मैंने example दिया था. That is, you can say it is a your smart material. If you put some electrical current, it will expand. If you disconnect, switch off, it will become contact. Expand contact, expand contact. So what will happen? It will expand contact, expand contact. So this philosophy we will use, and striking on the metal part, and will ultimately this is. So that is become one of the important process. Even another, this is a process, ECSM, electrochemical spark machining process. Electrochemical spark machining process. Sir, one thing I can ask you. I am asking you. Today, not only today, I say, after Stanisa Kahiri Devi, 30 years, Amitabh Bachchan is a good actor. Everybody knows. आपने देखा उसका पिक्चर? देखा ना? अच्छा लगता है कि आज भी अच्छा लगता है कोई किसी को सकता है everybody not funny. But I am not funny. But I given an example how आज का दिन में अगर अमिताभ बच्चन को मैं अगर हीरो बनाना चाहिए, बना तो सकता हूँ. प्रोड्यूसर जो पैसा दे रहे हैं वो बना सकते हैं किसी को. Now, you know, so if you make a fighting arrangement, Bachchan are able to fight because his age, I think he is about 73 or 74. 75. So it is he is not able to fight now with a villain. So what will you do if you are a producer or director? What will you do? You think you will arrange a dummy villain, a dummy fighter. हाँ, dummy fighter उसका face लगाओ, वो fight करेगा, but the Bachchan will fight him. मैं वही चीज करूँगा in the machine. I will do same thing in the machine. जैसे producer और director करेगा to make up the scene. Though Bachchan are in 73 of age, I know जे उससे fight होना नहीं. I know the non-conductive material cannot cut by the well-known non-conventional machining process. Even I use the conventional machining process, again it is very difficult because of your brittleness of this hard non-conductive material. Even thin sheet, I want to make a micro hole on a thin sheet of non-conductive ceramic. If you put the drill bit, immediate crack, immediately will become crack propagated rather than hole. Just like you bullet striking on the glass, what will happen? Crack rather than hole. So that's why we cannot recommend it. Even a conventional process, even a non-conventional process, where the anode himself is a non-conductive. Even chemical reaction will not meet explosives if it is a non-conductive as well also. That's why I will use some dummy fiber. So this is a electrochemical spark machining process. I will show you the picture. How? Here I will auxiliary anode I will use. Anode is this. It is a non-conductive ceramic. auxiliary anode I will use 100 times surface better, more than that of this. I will use here and then I will carve this material. How I will show it. This is one of the important thing. एक बार सर आप समझ में आया जो क्यों सर ये एग्जांपल दे रहा था. I have to do and I have to identify what are the solutions. Okay, these are the different cross processes. This is what I am telling you here. You see, this is mechanical micromachining processes. Here, one thing is important. You see here, these are the processes. You see here, this is a process, removal of material in the form of microchips in a ductile material. If it is this is a workpiece of material of ductile workpiece material. Clear? Then you see here, this is the abrasive particles will strike, apply force, and moving in this surface which will remove this material. But if it is a brittle material, what will happen? These are the cracks. This is a crack, this is a crack, this is a crack. Clear? Striking by this way, directly make a crack. Similarly, this is a coupler and tool, and you have put over here abrasive slurry like this way. This is a slurry. These are the different particles, and this is debris, and these are the particles which will become striking in between this. It is moving like this way. Just I am showing. It will be moving. So that slurry will passes with this. Slurry means there have some liquids and abrasive particles, or otherwise water and abrasive particles, otherwise gas with abrasive particles. Three things: liquid, water, or gases. Use gas and supply it. That can possible also. So this is the scenario of removal of this material. This is advanced micromachining. You see over here is a from slurry with this help of a pump, passes through the nozzles, passes like this, and this is the shape of the tool which is become moving, vibrating like this way, and make a removal of material in such a directions. And very good surface finish can be possible. This is also is a overcut. Overcut means, you know, slightly gap over there. Whatever may be the dimensions of the tool, that is overcut. Now this different nano finishing processes, you know, here abrasive flow finishing. Here abrasive flow finishing. This is become your one way and two way your die, where the plungers apply the force, and abrasive laden putty usually called, that is called, it is a media, which is media having some abrasive particles and some semi-liquid behaviors which is become can move up and down, and you will make the surface finish or make a whole finish like this way. Now this is a chemo-mechanical polishing. Here you see this is a surface, you put some slurry, this is a pad which is become, this is wafer carrier which is become rotate on the surface. Clear? And some of the you can put some here slurry is here in the nano level slurry similarly is some chemicals and some your particles in the nano powders. Here is also abrasive particles, that is 0.1 to 0.01 microns of size, average size particle. It will become passes through, and this is become a drum, that is polyethylene ball which is become rotating in this direction, and due to rotate some adhere will passes through in this direction, and it will create it will also move like this way and rotate. So it will apply pressure over here and surface can finish and remove this material. Similarly, lot of processes you see here. This is here also magneto abrasive finishing process. There is a lines of magnetic forces. You saw is a N pole, and accordingly it will rotate the magnetic particles, which is become abrasive particle use is automatically it will become striking over the surfaces and remove the materials. Here magnetorheological, here some rheological MR fluid are also put inside with these particles, and once it is rotated it will become striking on the surfaces and remove this material in the very good surface finish. Similarly here magnetorheological abrasive flow finishing process. Here you see, here also magnetic field, north and south pole, based on the lines of force, these are the particles will become rotates in these directions and can remove this particle like this way. So you can finish. Similarly here, this is a process of magnetic float polishing process. Float, rotate like this way. Float polishing. Float means, you know, just like a float chamber. सुना होगा नाम कहाँ? Yes, automobile in the carburetor. Float chamber. In the tank where the petrol का ऊपर float is floating. That's why it is a float chamber. Who is showing the needle how far the petrol inside the tank. Clear? So similarly, it will float on the surfaces and rotate, create a slight friction, and due to this friction, this will can remove the surfaces in the nano and angstrom level. Many of the application, some of the mirror finishing surfaces, some of these micro channel finishing surfaces, where the you can say defense and even your nuclear reactors and many things. Many of the things today we are using, because you know the micro machining process, the machining setup when you are manufacturing very small parts required to cool, required to remove the heat, required to supply the coolant. Always solid coolants are not recommended. So in that cases we have to supply this coolant in a very small micro channel and required to very good surface skinning of mirror finish. Otherwise it will stagnate and buoyancy of forces. Turbulent flow will create a buoyancy and opposes the flow of your lubricants and can burn or can bad effect due to your smart properties of these materials. Understand or not? So that's why the lot of places have these applications. Chemomechanical polishing, I have just showing over here, slurry drop wise on the pad, then wafer carriers with the carrier film, niche carrier film, that is wafer. I have also just telling you, wafer fabrication is nothing but that some electrons are become energizing, which will striking on the surfaces and stimulate this, changes their behavior on the surfaces. Finishing as well as change their behavior, implant some of the things to rise the properties. So that can process. Now ultrasonic machining process, you see here some of the tools and nozzles which is become vibrated. That is, I have also used the leads to energize the transducer windings. Transducer is nothing but that, you know, here. So that can increase and decrease. I have just explaining it is. So now it is one of the research work. Just I showing you. That's why I am not given to you people. Now I am entering the research work. Some of this, whatever maybe the basics I have given. Now it is the one of the research work. One of my student, he has developed this particular abrasive water jet cutting setup. Understand? And that setup, that's why I am not put into the, because it is in now progress for publishing in the research paper. Otherwise student will lose.